Hello, I just wanted to take a few minutes to go over some of the topics that are included in the first unit for Math 205. The first thing that we are discussing in example number 1 is we are given two sequences. The first sequence is an arithmetic sequence that starts with 1 and ends with 97. The second one is also an arithmetic sequence that starts with 1 and ends with 1005. Now, in the first sequence, the common difference is 1 because you are adding 1 every time. The first sequence is 1 plus 2 plus 3 plus 4. Keep on going and end with 97. The second sequence, we're starting with 1 and we are adding 2 every time and we're stopping with 1005. In the first sequence, to find the sum, we're going to use the formula for the sum of an arithmetic sequence. This is what your formula looks like. N is the number of terms in the sequence. A1 is the first term in the sequence, and AN is the last term in the sequence. So in this particular problem, A1 is 1. AN is 97, and then we need to find out how many terms there are starting with 1 and ending with 97, which would be 97. So I would set this up as 97 over 2, 1 plus 97, and this will give me the sum, which is 4,753. Now, example number 2 is basically the same thing, but it's a little bit harder to find the number of terms. When we're dealing with a number of odd numbers beginning with 1 and ending with 1005, to find out N, we would need to take 1005, subtract 1, that would be 1004. Then I would need to divide that by 2 because we're only dealing with every other number. So I would end up with 502 terms. Now, this does not count both 1 and 1005. This only tells us how many are from 1 to 1005. So I'm not adding in both endpoints. So when you use this, you always have to go back and add 1. So there's actually 503 terms. Now I divided by 2 because we were counting by 2. So if I was counting by 5, I would divide by 5. If I was counting by 10, I would divide by 10. But you always have to add 1 at the very end. Same thing over here with example 1. If I use this method, I would take 97 minus 1, so that would be 96, add 1, so 97 terms. Now the rest of the problem follows the same. I would set up the sum. There's 503 terms divided by 2. The first term is 1 and the last term is 1005, which ends up with a total of 253,009. Now moving on to example number 2. We're still doing the same thing, but this time when we're finding our sum, we are starting with 53, counting by ones, and we're ending with 144. So to find the number of terms, I would take 144 minus 53. I don't have to divide by anything because we're counting by ones, and then at the very end I need to add 1. So when I do this, I end up with 92 terms. So to find the sum, there's 92 terms divided by 2. First term is 53. The last term is 144, which would give us a sum of 9,060. Sorry, that's 62. It's 9,062. Now, when you're doing example number 3 and you're making that chart, it's really important that you follow a pattern on the chart, or it's very easy to leave one out. Just wanted to Now I want to continue our conversation a little bit by moving on to section 1.2, and we talk a little bit about arithmetic sequences, where that's where you're adding a common difference. Geometric sequences is where you are multiplying or dividing by a common number, which is called a common ratio. Now you have two more formulas introduced. The first one is for an arithmetic sequence, and you take the first term, multiply that by n minus 1, and then distribute that by d. So this stands for just finding a specific term. Formula for a specific term. Now that's for arithmetic. Now for geometric, same thing. This time you take the first term, multiply it by the common ratio, and your exponent is always n minus 1. Now remember that n stands for number of term. D is your common difference. A1 is your first term in the sequence. So when you go down to example number 1, the first sequence that you're looking at is 1, 13, 25, 37, 49. You're adding 12 every time, so it's arithmetic. Common difference is 12, and then just continue the pattern, and so on the rest of number 1. Now on number 2, you are actually finding the 11th term. So I look at the sequence, and I see that I am multiplying by 3. So that makes this a geometric sequence, and the common ratio is 3. So I'm going to use this formula to find the 11th term. So I want to find the 11th term. So I would take the first term, multiply that by 3, and raise it to the 11 minus 1 power, which would be 2 times 3 to the 10th power. Now you cannot make that 6 to the 10th power. In order of operations, you have to evaluate the power before you multiply by 2. So if I take my calculator, put this in my calculator, I would end up with 118,098, and that would be the 11th term. The next one I want to look at is number 3. Now there's 2 steps to this problem. The first step is I need to find the common difference. So I know the first year that the price of the car was $23,600. So that's A1. And then I also know that in the 12th year, the price was $32,400. Now I'm going to use these two values, and I'm going to figure out what the common difference is. So I'm going to take 32,400, set it equal to 23,600 plus n minus 1 common difference. Now n in this case we're going to let be 12, so this is actually going to be 12 minus 1. The formula that I'm using is AN equals A1 plus D times n minus 1. Now I'm going to solve this, and I end up with 32,400. This would be 11D. Then go through and solve the equation, and you end up with D is 800. Now the second part is I need to figure out in what year would it cost 36,400. So using the same formula, I'm going to take 36,400. The first year is still 23,600. I don't know what year, but I do know that the common difference is 800. Here I'm going to go on and distribute. So after I distribute the 800, now I'm going to combine like terms. And then once I go through all the math and solve for n, I get n as 17. And that's the answer to the second part.